Quick, graph y equals 3 minus 1/2 raised to the x power by hand 2 different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. First, we need to decide what the parent function is and its shape. Parent function is y equals 1/2 raised to the x, and its shape is this, an easy chair that's facing the other direction from the y equals 2 to the x. We need to identify the parameters. These are values in the expression that affect the graph. But first, we need to rewrite this equation in a more useful equivalent form. So I'm just going to rewrite this as the opposite of 1/2 raised to the x plus 3. Just makes it easier for me to pick out the parameters. There are 2 of them. How do they affect the graph? Well, the plus 3 shifts up all points 3 units, including the asymptote, which was normally at y equals 0, but now is shifted up to y equals 3. And it also affects the so-called new origin. The new origin will be at 0, because none of this affects the x-coordinate, comma 3, because everything's shifted up 3. So we'll go ahead and plot 0, 3, and all points will be plotted relative to this new origin. The opposite sign takes the opposite of each of the y values, and so we're going to use the 1/2 to the x dance, which starts off right 0, up 1. But in this case, it's going to be right 0, down 1, because we take the opposite of each y value. And recall that 1/2 raised to the 0 is 1. Normally we go right 1 up 1/2, but here we're going to go right 1 down 1/2. And recall that 1/2 raised to the first is 1/2. Right 2 up 1/4 becomes right 2 down 1/4. 1/2 raised to the second power is 1/4. Going in the other direction, normally left 1 up 2, but we're going to go left 1 down 2 because that opposite of the y values. Remember, 1/2 raised to the -1 is the reciprocal of 1/2, which is 2. And left 2 up 4 becomes left 2 down 4. Recall that 1/2 to the -2 is the reciprocal of 1/2, which is 2 squared is positive 4. But again, we're taking the opposite. Connect the points to look like an easy chair, but this one's kind of upside down because of that negative sign. When we compare it to the parent function, you can see that. Second way, using a table. Again, we want to rewrite as an equivalent form because I think it's easier to deal with. Here are 5 points on y equals 1/2 raised to the x parent function. So the opposite sign takes the opposite of each y value. The plus 3 adds 3 to each y value. So which do you do first? Well, neither of these parameters affect the x values, so those values will be staying the same. So we'll just make those the same. But the order of operations tells us which way to do these, and we always take the opposite first, add 3 second. So doing that, the opposite of 1/4 plus 3, we're going to show that calculation over here. That's -1/4, and think of 3 as 12/4, so that we get 11/4. So plot 2, 11/4. We suggest that you pause, finish the table in the graph, and resume when you're ready. The opposite of 1/2 is -1/2, plus 3, which is 6/2, is 5/2. So 1, 2.5. The opposite of 1 is 1. -1 plus 3 is 2. So 0, 2, the y-intercept. The opposite of 2 is -2 plus 3 is 1. -1, 1. And the opposite of 4 is -4 plus 3 is -1. -2, -1. Draw the asymptote, and it appears that the asymptote is going to flatten out at y equals 3. So we'll draw that in. And then we connect the points to get that easy chair looking curve compared to the parent function. Now you try one. Graph y equals -2 times the quantity of 1/2 raised to the x minus 1. Use either method or both for the practice. Press pause right now to do this and resume when you're finished to check your answer. And here's your answer, the graph in green and also the table here in green.